All right, before we take a look at your homework, I want you to take just a moment to work on a classwork problem here. We've got 2 points, J and N. I want you to find the length of JN, that segment. I want you to find the midpoint of the segment JN. Then if you would, find the slope of a line parallel to JN, perpendicular to JN, the angle of inclination of a line parallel to JN, and the angle of inclination of a line perpendicular to JN. Pause the video while you work, and then once you're finished, go ahead and resume the video. All right, let's see how we did on this classwork assignment. What did you get for the length of line segment JN? Jamie?
13.
Comes out evenly to 13 units, right? What did you get for the midpoint of JN, Quentin?
Negative 1/2, 1.
Negative 1/2, 1. Now, when it comes to finding the slope of a line parallel to JN, obviously the first thing we ought to do, Jamie, is find
The slope of the line.
the slope of JN. And what is the slope of JN here, Jamie?
Negative 12/2. 12 over 5.
Negative 12/5. So what is the slope of a line parallel to JN?
It would be the same thing. Negative 12 over 5.
Negative 12/5. What about the slope of a line perpendicular to JN? Quentin?
5/12.
Positive 5/12. What about the angle of inclination for a line parallel to JN? Quentin?
112.6 degrees.
Good. Initially you get that negative 67, but end up adding the 180 to get 112.6. And then what about the angle of inclination of a perpendicular to JN? Jamie?
0.01 degrees.
Arctangent, not tangent, arctangent to get the angle.
You still use this 112.6.
Okay, so remember, angle of inclination is the arctangent of the slope. So if I want the angle of inclination of a perpendicular, I'll take the arctangent of the slope of the perpendicular.
22.6.
Though there is another way that we could have gotten 22.6. Thoughts, anyone? I didn't technically have to take the arctangent of
Did
this.
you take the negative reciprocal of the
A perpendicular is going to be 90-degree different from a parallel, correct? And if I added 90, that'd be too big, so I'd have to subtract 90 and get the 22.6. That's the other way I could have found it. I think it makes a great way to check, perhaps, but that's another way we could have found that. Anyone go 6 for 6 on the classwork? All right, Jamie? Okay, any questions at all? And obviously, if you're watching, you have questions, be sure to send those questions to me. Let's take a look at your homework now, page 214. In your textbooks, you did number 2C. 2C. Robinson Crusoe wanted to go. Have you read that yet?
Yeah.
It's recently?
Somewhat.
I say that's one of the selections I teach in summer school if I have to do senior year summer school. I don't do all the literature because I don't have time, but I do Robinson Crusoe and I do Pilgrim's Progress. Those are the big two. Page 214, 2C. And it says to find the locus of points equidistant from 0, 0, and 2, 6. Equidistant from 0, 0, and 2, 6. Now there are 2 ways you could do this, and I'm curious, Jamie, which way did you do this?
I did the distances equal to each other.
Good, there's a third point, right? In fact, there's an infinite number of points in the locus, and every point in the locus class could be represented
X and Y.
x, y. We don't know its coordinates, so just call them x and y, right? X, y. So the distance from xy to 0, 0 is going to equal the distance from xy to 2, 6. If we know those distances are equal, I can replace the distance with its own formula. The square root of x2 minus x1 squared plus y2 minus y1 squared. And then I can take this distance as well. x2 minus x1 squared plus y2 minus y1 squared. And Jamie, that's how you set it up. Quentin, did you do the same thing or did you use an alternate method?
Same way.
Same way. I think this is probably the most direct way, especially since while it looks awful with those radicals at the outset, what's going to happen to the square roots?
Just drop off.
Yeah, they're going to drop off because you're going to square both sides and they're just going to vanish basically, right? And here, this just becomes x squared plus y squared. That's really not that bad. The meat of the work is squaring some binomials. Quentin?
X squared minus y plus 4 plus y squared minus 12y plus 36.
There we go. And thoughts next, Jamie, to make this even a little bit easier?
To cancel all the x squares and y squares.
Yeah, cancel the x squares, cancel the y squares. Notice I've got an x here and a y here. They're both negative. I'm going to move both of them over to make them positive. Quentin?
4x plus 12y.
And then we'll combine the constants that are left.
40.
40. I'm not going to leave the answer this way, though, because I always try to simplify answers, right? We like things to look easy. What can I finish it out by simplifying, Jamie?
Take out 4.
To get?
X plus 3y minus 10. Or, that's how I do it.
I think equals 10, or minus 10 equals 0, but equals 10 would be the easiest way to leave that. And there's the equation of our line, the perpendicular bisector of the line segment joining the points. And we could have, I suppose, found the midpoint, 1, 3, found the slope of this line, gone with the perpendicular slope and gone from there. But this, to me, is the most direct way to work 2c. Did we get this equation?
Mm-hmm.
Right, any questions on 2c? Drop down, if you would, to 2h. 2h, this is an interesting one. We're finding the locus of points equidistant from negative 2, 3, and the line y equals negative 4. Now picture this for a moment. We're going to picture it before we do it. We've got a line, y equals negative 4, and we've got a point, negative 2, 3. They want all the points that are equidistant. Well, obviously, if we went like halfway, that point would be equidistant, right? But if I went, for instance, this far, I need to be that far as well. If I went like this far, I need that far as well. So maybe something like this. And we're going to end up getting an interesting shape formed here. Now here's the question. What is this point on the line? I don't know. But I know its y value is negative 4. I just don't know its x value. I could call it x negative 4. What about the coordinates of this point? What are its coordinates? I don't know. But if it's in the locus, I would call it xy. Anybody would say, well, that's x negative 4 up there. Well, this is also x negative 4. I just don't know which x value, right? It's just any x value. But I do know that the distance here from xy, a point on the locus, to negative 2, 3, and the distance from this xy, or this xy, or this xy, or this xy, whatever, to x negative 4 is also the same thing. At your seats. Finish that out. I've got equidistances here. One from a point, another from a line, but I can represent every point in the line as x negative 4. Take just a moment to work. Do we start this way? X plus 2 squared plus y minus 3 squared, square root of all that, equals x minus x squared plus y plus 4 squared.
On this, I had an x minus 2 at the start instead of.
I got you. Instead of the negative 2, so minus the negative gives the positive. How'd you do?
Right.
Got it?
Mm-hmm.
What shape is this? One variable squared, but not the other variable. Parabola. And in fact, that's how you define, we're going to talk about parabolas more later, that's how you define a parabola. It's actually the locus of points equidistant from a given point and a given line. So, we'll talk more about the parabola in days ahead. Let's take a look at number 4 now. Read 4 through part A. Number 4 through part A for me. Jamie?
Find the equation of the line passing through a 2, -2, and having a slope 3.
All right, so they want the equation of the line. They give us the slope, and they give us a point that it goes through. Well, we understand that if I just gave you a slope, there's an infinite number of lines that can have the same slope, that would be parallel. But through a particular point, well, you could draw an infinite number of lines through a particular point, only one line can be drawn through a point with a given slope, right? Any other line through that point would have to have a slightly different slope. So this does define a singular point. The slope is 3, and it goes through the point to -2. Well, every time it talked about equidistant, or twice the distance, or the distance of what? Every time it talked about distance, we used the distance formula. Well, this problem doesn't talk about distance. It talks about slope. What do you suppose we should do? Slope formula. What is the slope formula?
Change it. Or y2 minus y1 over x2 minus
And again, this line has an infinite number of points in it. One of them is 2, -2, of course. But there's an infinite number of other points in that locus, that set of points that's defined by having this slope and through that point. Any other point in the line could be called xy. So, in place of the m class, I could put 3, because I know the slope, or 3 over 1. For y2 minus y1, I should write
y minus, or y plus 2.
y plus 2, y minus -2, and for x2 minus x1,
X minus 2.
x minus 2, just like we did change in x and change in y. Now they were squared in the distance formula, of course, but we set it up that way. And now we've set ourselves up a proportion. How do we solve proportions? Cross multiply. Product of the means equals the product of the extremes. And if I multiply the extremes and then the means, and switch some stuff around here, I could get 3x minus y equals 8. Or, if I did the means first and then the extremes, I could get slope-intercept form. Do you remember slope-intercept form from our long ago algebra days? Right. So either answer would be acceptable. This is the more pleasing with the xy on one side and the number on the other, but slope-intercept form would work as well. Does that make sense? Just use the slope formula. Look at letter C. Look at letter C. There's a line that goes through 0, 0, and 5, 6. Well, we of course know 2 points determine a straight line. We could find the length of the line, certainly, the midpoint of the line, the slope of the line, the angle of inclination of the line, but they want the equation that describes all the points that go through these two. They want the equation of that line. Well, last time we used the slope formula because they gave us the slope. Here they don't give us the distance or the slope.
They give us point so we can find the distance.
Or the slope. Which formula is easier? Distance formula might give me a radical. I hate radicals. Slope formula gives me a fraction. I don't have those as bad. Let's get the slope. Last problem was pretty straightforward because they gave us the slope. Let's find the slope, and we could do that in our heads.
6/5.
6/5. All right, now let's take another point in the line, call it xy. And so we've got the slope, and then we've got this point xy. Now, last time we had xy, and we had one other point. Here we have xy, and we've got two other points. Well, let's just pick one of them.
0, 0.
0, 0. Absolutely. And let's say that 6/5 equals the change in y minus nothing, over the change in x minus nothing. And when we cross multiply, what's our equation?
6x equals 5y.
Good, 6x equals 5y. We could, I suppose, say 6x minus 5y equals 0, but there's nothing wrong technically with the other. Does that make sense? All right, so look at letter E, very similar. We've got the point 0, 2, and we have the point 5, 3. We also have a whole bunch of other points in the line, which we could just generically refer to collectively as xy. Again, that's really the key to these locus problems, is there's always a point in the locus, or in the line in this case called xy. And again, it'd be really easy to find the equation if I just knew the
Or slope.
the slope. Well, again, I'll say this too. The distance formula, I'm like, could I use the distance formula? Well, is any point xy in the line going to be the same distance as these 2 points are? These 2 points are the end points. Any other point would have to be a different distance, wouldn't it? Yeah, distance formula really wouldn't work here. But the slope would, because no matter where xy is in the line, it's still in the same slope as all the others, right? So let's find the slope. Call it when you got it. 1/5. All right, so let's take the slope. And the top, let's take the change in y. Jamie?
Would it be like y minus 3?
You could, and then over.
X minus 5.
Now, I would have liked to say y minus 2 over x minus 0 because they're easier numbers, but there's nothing wrong with this. Are you doing the 0, 2 by any chance, Quentin?
Yes.
Hey, then that means we can confirm we have the same answer. All right, so Jamie, talk me through it as you do it at your seat.
You cross multiply and get 5y minus 15 equals x minus 5. Then we can just rearrange and move the 5y over to have a negative 5y, and move the negative 5 over as a positive 5, and get negative 10.
There we go. Or x minus 5y equals negative 10. Is that what you had with the 0, 2? So it doesn't matter which of the points you pick, right? Because they're all in the same line anyway. But maybe it's slightly easier math with the 0, 2 than with the 5, 3. All right, questions on this? All right, drop down to number 5 now. Read up through part A if you would. Quentin.
Find the equation of a circle whose points are distance 2 from 0, 2.
Oh, okay. Now we've seen this recently, right? Distance. So that implies distance formula, right? So we've got this point, 0, 2. We've got this circle that goes around. That's the locus. That's the equation we're finding. And it says that the distance is 2. What do we call any point in the circle, class? xy. And the distance from xy to 0, 2 is a distance of 2. At your seats. No rush. had?
I had almost the same answer, but I did it a different way. But
Ooh, how did you do it?
I was saying the distance is equal.
Oh, but there's not two equal distances though, are there?
Right.
Well, unless you said there's another point which we could also call xy, and then this distance equal, but that would be really hard. We know the distance.
Right.
Just like in the last couple problems, we knew the slope, well, after we found it. So put it in where the m is. If you know the distance, put it where the d is.
Mm-hmm.
Does that make sense? Let's look at letter D. This is a fun one. Letter D. Read 5 through part D for me there, Jamie.
Find the equation of the circle whose points have endpoints of one diameter at 3, -2, and -5, 4.
All right, so we know we've got some circle. And obviously in a circle, there's an infinite number of diameters you can draw. We choose to draw this one. It's a terrible circle, I know. And the endpoints of the diameter are 3, -2, and -5, 4. All right? They want us to find the equation of the circle. Well, the last time we did this, we used the distance formula, right? And the distance formula is great for a circle because a circle is the locus of points having a given point as center and a given distance as radius, remember? How would I use the distance formula in something like this, though?
You could find the midpoint.
So if I found the midpoint of the diameter, that would be the center of the circle. Okay, what is that midpoint? -1, 1, right? You add and divide by 2. Add and divide by 2. So that's the midpoint, okay? So if I had another point on the circle, which we call class xy, it's got to be the same distance to this point as this distance is, right? As this distance is, as any other distance is. Or we could find that distance, couldn't we? Not this one, but this one or this one. What is that distance? What is the length of the radius of our circle? Get it from Jamie when she's got it.
Radius would be 10.
Would it? You found this distance, didn't you?
Yeah.
This distance is 10, but that's the diameter. So what's the radius?
5.
5. So if these radii are 5, then this radius to the random point xy is also 5. I know the distance is 5 from any point to the center that Quentin gave us. Same thing now that we did last time, or should have done last time. Go and find the equation of the circle. In for the D, class, I can replace the letter D with what value? 5, because that's the distance. All the way around from this point is a distance of 5 to any xy point you choose. And that distance of 5, remember, is between any xy point and the point -1, 1. How do I show the change in x, class?
X plus 1 squared.
X plus 1 squared. How do I show the change in y?
1 minus 1 squared.
Questions so far? So you're like, well, it's not a distance to 3, 2. No, 3, 2 is not at the center, right? It's not a distance of 5 from 3, -2. It's 5 from -1, 1. The -5, 4, and the 3, -2, really their only purpose was to help us find this midpoint. and then to allow us to find what that radius would have to be all the way around. As we finish out here, Jamie, what should I do next?
We should square the binomials and get x squared like 5 equals
5 equals?
yeah, and get 25 equals the binomial square, so, and x squared plus 2x plus 1 and y squared minus 2y plus 1.
There we go. And then if I wanted to simplify a little bit, we could, I suppose, get the squares together. We could put the first powers together. And then we take these two 1s and kick them out and make them negative to get a 23, or set it after and say equals 23. And that's perhaps the best way to write it, though I'm not too picky on how we write our equation at this point. Did we get something like that, Quentin?
Mm-hmm.
And then Jamie, you're still kind of working on it. Does it make more sense now? All right. Let's suppose I knew that my circle has a center at 3, 5, and the radius of 2. Find for me the equation of that circle. Or you could say the locus of points, a distance of 2 from the point 3, 5. All right, Jamie, how do we set it up?
2 equals the square root of x minus 3 squared plus binomial square root of 1 minus 5.
There we go. All right, then?
Then we square both sides to get rid of the square root, and it's 4 equals, and then we can go ahead and square the binomials and get x squared minus 6x plus 9 plus y squared minus 10y plus 25.
And then Quentin, if I want to get it looking really nice, what might I do?
A squared plus y squared minus 6x minus 10y equals -30.
There we go, and that's perhaps the best way for it to look. Again, it's not got to be quite in that form, but that sure looks nice. With the squares, the first, and the constant kind of off to the side on its own. We can see the circle, because we can see both squared, added, and equal numbers there. Questions on this? All right, go to clear desk, if you would, please, except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else away. Clean sheet of paper and a pencil. Everything else off your desks. First and last name at the top of your paper, along with today's date, which is 2/25/22. So just 10 months till Christmas, and so be thinking about presents for favorite former teachers, because at that point, unless of course we really, really struggle as we finish out the year. Just kidding, we're gonna do fine. All right, first and last name, this is Quiz 33. Quiz 33. All right, so we'll take a look at the quiz together very quickly. Number 1, I give you a couple of points. You're going to use those points to do everything 1 through 5. On 4 and 5, remember, anytime you're finding an angle, it's 1 decimal place is what we're looking for. And then numbers 6 through 9, write the equation for the described loci. Now 6 and 7 are going to be pretty straightforward. Not going to have to spend a lot of time there. 8 and 9, you're going to have to actually do a little bit of math to figure those things out. All right, any questions before we start? All right, I'm going to put the homework on the board, and then I'll end the video here. So you can pause the video, take your quiz, and then you'll have the homework on the board.